Hi students, in this section we'll deal with questions involving division and remainder. Alright, so these are the three types of situations that we will discuss. We have already seen the first case in Chinese remainder theorem. Let me say an example. Say there is a boy AB and say he has a certain number of books, he has n books. Now if he takes 7 books at a time out, he is left with 0 books. If he takes 8 books at a time out, he is left with 3 books, right? Now it's asked what is the number of books that AB has. So this type of a question, if you convert it into an equation, it's written like this, right? It's mentioned that when he takes 7 at a time, he's left with 0. That means the number of books that he has is a perfect multiple of 7. So I can write it as 7a. And it's also mentioned that if these n books, he's taking 8 at a time out, he's left with 3 books. So n is 8 into some multiple plus 3, right? Because he's getting a remainder of 3. Now this type of an equation, let's quickly see how you can solve this. We have seen that in the Chinese remainder theorem section, but let's quickly revise. Over here I can write 8b as 7b plus b, right? So let me take that 7 to the left and that becomes 7x is equal to b plus 3, right? Over here I have 7a and I write this part over here as 7b plus b, right? And I take this 7b to this side. So I'm getting 7 into a minus b and I write a minus b as x. So I have 7x is equal to b plus 3. Alright, now after having established this, it's just a matter of trial and error to find one solution, any one solution. So you can easily see that when you add 4 plus 3, you will get 7, right? 4 plus 3 is equal to 7. So one solution of b is equal to 4. Now over here we have 7a is equal to 8b plus 3. So substituting b as 4 over here, 7a is equal to 8 into 4 plus 3, that is 35. So a is equal to 5. So I have got one solution. I have seen b is equal to 4 and a is equal to 5. Now over here you can see that the equation is 7a is equal to 8b plus 3. Now answers of a will move in steps of 8 and answers of b will move in steps of 7. So the next answer or solution that b can take would be 4 plus 7, which is 11. Now the next solution for a will be 5 plus 8, which is 13. So let's check whether that works. What is 11 into 8? 11 into 8 plus 3, right? That's 88 plus 3, which is 91. Now 7 into 13. What is 7 into 13? 7 into 13 is also 91, and you can see that they are equal. So this is correct. Now what would be the next solution over here? It would be 11 plus 7, that's equal to 18. And similarly the next solution over here would be 13 plus 8, which is 21. And it moves like that, right? You can also move back. Like if you want to go in this direction, you have to do 4 minus 7. You will get the answer as minus 3. And you have to do 5 minus 8. Over here also you will get minus 3. Let's see if that works. 7 into minus 3 is minus 21. 8 into minus 3 is minus 24 plus 3 also gives you minus 21, and these two are equal. Alright, so we have seen that b moves in steps of 7 and a moves in steps of 8. Alright, let me make some space over here. Now in this question which I described over here, we had to find the number of books AB has, right? Therefore n, which is equal to 7a, which is equal to 8b plus 3, is of the form 7a equal to 8b plus 3. This also will be an arithmetic progression, and the first term over here to get, you just substitute either b is equal to 4 or a is equal to 5. So 7a is n, right? When a is 5, 7a is equal to 7 into 5, that is 35. So you have one solution, and you can see that n moves in steps of the LCM of 7 and 8. The LCM of 7 and 8 is 56, right? It's 7 into 8 itself because 7 and 8 are co-prime. So the next answer of n over here would be 35 plus 56, which is 91. So let's try whether that is true. when a is 13, what is 7a? 7 into 13, which is equal to 91. So this is valid. The next solution of n would be 91 plus 56, which is equal to 147. Right. Now let's keep this aside. And we have seen how to solve this type of an equation and find solutions. So in the question we had seen any of these could be the solution if, as per the options, 35 or 91 or 147 can be the number of books that AB has. All right. Now over here, these two remaining sections over here, these also can be solved in the same way that we discussed over here, but these have a method of solving even faster than the method that we discussed over here. So let's discuss that. Hi students, so far we have discussed the generic method which can be employed to solve any of these equations. We have seen how it is used to solve this equation over here. Now the same method can be used to solve the second and third equation also, but these two are special cases which we can solve faster. So let's discuss other ways in which we can solve them. All right, now let's start with the second case. Let's take an example of a question. A boy has a certain number of toys. Let that number of toys be n. If you take out 7 toys at a time, you will be left with 1 toy. So that means n divided by 7 will give you a remainder of 1. And it says if you take out 8 toys at a time, you will be left out with 1 toy. So that means n divided by 8 also gives you the same remainder, which is 1. Now over here you can see 7a plus 1 and 8b plus 1. So this is the same, right? These type of questions, if you want to find n, right, over here this is n is equal to 7a plus 1 is equal to 8b plus 1, right? This type of numbers will be an arithmetic progression. Now let's try to understand how we can find the generic term of this arithmetic progression. All right, the first step is find the LCM of 7 and 8, which is 56, because they are co-prime. So the LCM of 7 and 8 is 7 into 8, which is 56, and the generic term for this arithmetic progression will be 56k plus 1. So what are all the numbers in this AP? If k is equal to 0, you will get 1. If k is equal to 1, you will get 57. If k is equal to 2, you will get 113, and it goes on like that. All right, now let's see if this condition is satisfied. Say in the case of 113, if you divide 113 with 7, you can see you will get 16 and your remainder is 1. If you divide 113 with 8, you can see that you will get a quotient of 14 and your remainder is 1. So in both these cases, you're getting your remainder as 1. Therefore, this is valid, and the generic expression in this type of an equation is the LCM of this number and this number, and then to that you have to add the common remainder that you are getting. All right, let's keep that aside and let's go to the next one. Over here, you can see 7a plus 2 is equal to 8b plus 3. So what is the interesting pattern over here? Let's take an example of a question. A girl has a certain number of toys. If you take out 7 toys at a time, you will be left with 2 toys. If you take out 8 toys at a time, you will be left with 3 toys. Now, that's similar to what we've seen before. So if the number of toys is n, it's given that n divided by 7 gives you a remainder of 2, and n divided by 8 gives you a remainder of 3. Now here you can see that the difference between 7 and 2 and the difference between 8 and 3 both are equal, right? That's the speciality of this type of an equation. Over here the difference is 5 and over here the difference is 5. Now if you want to solve this type of an equation, all you need to do is you need to find the LCM of 7 and 8 and you have to subtract 5 from it. So that amounts to 56 minus 5, which is 51. The generic expression of this arithmetic progression will be 51 plus 56k, right? So when k is equal to 0, you will get 51. When k is equal to 1, you will get 107. When k is equal to 2, you will get 163, and it goes on like that. Now let's see some interesting thing about these 3 equations. You can see all the 3 cases where arithmetic progressions where the common difference is equal to 56, right? Over here we've seen 56k plus 1. That's what we got in the second case. In the third case, we have got 51 plus 56k, right? And in the first case, what was the condition? Over here we can see it's 35 plus 56k. So in all the three equations, because it's 7 and 8 over here and these are co-prime, right? So the LCM of 7 and 8 is 56. So in all the three cases, we got arithmetic progressions with common difference is equal to 56. Now the method we used over here can be employed in all the cases, but the second and third case are special cases, and if you get a question of type 2 or type 3, you can do it very fast, right? What's the specialty of type 2? The remainder is the same, right? So all you need to do is you need to find the LCM, and LCM is 56, and 56k plus the common remainder is your generic expression. Now about case 3, you need to find the LCM and you have to subtract the common difference. Over here 7 minus 2 is 5, over here 8 minus 3 is 5. So 56 minus 5 gives you 51, and the generic expression is 51 plus 56k. Hi students, let's do this question. A shelf has a capacity of 500 books. N books are kept in the shelf. If you take out 3 books at a time, you are left with 2 books. If you take out 5 books at a time, you are left with 3 books. How many values can N take? Pause the video, give it a try, and then we'll do it together. Alright, we are back. I hope you have given it a try. It's mentioned that there are N books, and if you take 3 books at a time, you are left with 2 books. So I can write N as 3a plus 2, right? Similarly, it's mentioned that if you take 5 books at a time, you are left with 3 books. Therefore, I can write N as 5b plus 3. Alright, and also the capacity of the shelf is 500. So N has to be less than or equal to 500, right? Alright, now over here, I have 3a plus 2 is equal to 5b plus 3. Now let me take the 2 over here to the right hand side. So 3a is equal to 5b plus 1, right? Now 5b can be written as 3b plus 2b, and let me take 3b from here to the left. So on the left hand side, I'll have 3a minus 3b. This can be written as 3x, and 3x will be equal to 2b plus 1 because I've taken 3b from here. So I'm just left with 2b. Now I just need to find one solution for this equation. I can easily see that when b is equal to 1, I get 2 plus 1, which is equal to 3, and x can have a value of 1. So it satisfies the given equation. So b is equal to 1 is one of the solutions for this equation. If I substitute b is equal to 1 over here, I'll get 5 plus 3, that's 8. So 8 minus 2 is 6. So 3a is equal to 6, or a is equal to 2. And in this case, n is equal to 5 plus 3 or 8. So this is one possible solution. So I could fill the shelf with 8 books and the given condition would be satisfied. But the question asks us how many values can N take. So how many values can N take? So over here, the limiting criteria is that N has to be less than or equal to 500. Alright. And we have seen that in this type of equations, N will move in terms of the LCM of 3 and 5, which is 15. So the next term of N would be 8 plus 15, which is 23. The next one would be 23 plus 15, which is 38. And it goes on like that up to 500, right? Now, if you take the first 500 natural numbers, and if you want to see how many multiples of 15 are there in the first 500 natural numbers, all you have to do is you have to do 500 divided by 15. That's 33 point something. So your answer over here will be either 33 or 34, depending on what the starting term is. Over here, you can see that you're starting with 8, right? So if you take 15 into 33, you'll get 495. Now over here, if you add 8 to 495, so 495 plus 8 will be more than 500, right? It will be 503. So you cannot take 33. You have to take 32. So over here, 8 is nothing but 8 plus 0 into 15, and the next one 23 is 8 plus 1 into 15, and you can go up to 32. That would be 8 plus 32 into 15. So 0 to 32, that's 33 numbers. 0 to 32 will give you 33 numbers, and your answer will be 33. And what's the last number over here? It's 8 plus 32 into 15, which is equal to 488. So the values that n can take is 8, 23, 38, etc. up to 488, and there are a total of 33 values that n can take.